Okay, here's a good guide for how we use what we call the first derivative test. And it's everything I just said in that last video. Find all your critical points, every place where the derivative is 0 or does not exist. And then we're going to draw a number line and figure out if the derivative is positive or negative in each region of that number line, and use that to figure out whether our graph is going up or downhill. Okay. So here, I already have the graph of the derivative. I'm going to use that to sketch out what the original function might look like. So we're kind of building up to full curve sketching. We're not there yet. Somebody's handed me a graph of the derivative. I want to just quickly sketch f, a possible graph of f. They're actually going this direction. They're an infinite number. And we'll see later once we get the second fundamental theorem of calculus. But for now, we're just going to sketch a possible graph of f. Okay, so let's look here. Here are my critical points here. Every place the derivative is 0 or does not exist, in this case, all of those are just 0. We don't have any does not exist. In this whole region, the derivative is positive. So that means my graph itself is going to be going uphill, increasing between -2 and 1. And there's going to be some kind of either a max or a min right there at -1. Then in this region, from -1 to 0, the derivative is negative. Remember, up here is positive, down here is negative. The derivative is negative in this entire region. That means the graph itself is going to be decreasing. Increasing is positive, decreasing is negative. Look in this region here. Between 0 and 1, the derivative is positive above the x-axis. My graph is going to be going up. Between 1 and 2, the derivative is negative down below the x-axis. So my graph f will be going downhill. So I'm going to go uphill, downhill, uphill, downhill. So that spot there at -1, I went from going up to back down. I'm going to have a max right there, a local max, because I went from increasing to decreasing. So I'm going to go ahead and put that in here. So right there at -1, I'm going to have a local max, and the graph was decreasing before that. I've got something happening here, someplace where the derivative is 0. So I've got a critical point back there at -2. F went from increasing, see how I'm going uphill, to decreasing. It switched over and passed through 0. Right there, the derivative is 0. Because look at my tangent line. My tangent line's horizontal. Remember, derivative of 0 is at the tops of hills and bottoms of valleys. In this whole region, my graph needs to be decreasing until I hit 0. So decreasing, maybe let's say to there. And then increasing again. See, I'm going from down to up. The graph is doing something like that. Back up. Right there is a local min. Anytime you're going from decreasing to increasing, you're at the bottom of a valley. In this whole region from 0 to 1, the graph is going uphill because the derivative is positive. Derivative tells you which way you're going, up or down. So I'm going uphill, and then now I'm going downhill. I have to go from up to down, uphill, downhill. So I've got here a local max. Right there at that spot, at 1. At is the location. I don't know what the Y value is, don't really care at the moment. And then for this entire region, the derivative is negative. So that means I'm going to keep decreasing. I'm going down. I don't know how far down, but I'm going to be decreasing until I level off again. So the derivative is more and more negative. I'm getting steeper and steeper, but then it becomes less negative. I went way too far there. It becomes less negative. See, look, that negative value is not as negative as that negative value is. The more negative the derivative is, the steeper the curve is, but then it's going to become less and less steep until it comes back to some kind of critical point again. That's a poor drawing. So right here, I'm going to have some place where the tangent line would be horizontal. So this is a rough sketch of what this guy's anti-derivative would look like. Okay, that's a good place to stop in that one.